program whereby he will incorporate into his computer a list of every home in his area and whether or not that has cable, and he will use that for different marketing approaches, so that he'll send literature to those homes that are not on the cable system. It'll be used for inventory control. We're using it for keeping track of what parts you have in stock, when certain components need to be reordered. It'll also be used for accounting and bookkeeping functions, as it's been mentioned many times before. You can buy many packaged programs that will do your bookkeeping and accounting for you, and I'll get described later some of the computers you can use for that in an easy, inexpensive way to go about doing that. Micros will also be used in the office for word processing. Now, if you're not familiar with word processing, it's a fairly simple concept whereby instead of typing letters and other written matter directly into a typewriter and onto paper, you type it into a computer and then use the computer's power to edit the functions. For example, you could use it for form letters. When you wanted to send the same type of letter to a variety of people, you could type in the letter into the computer and just change the addresses so that your form letter could be typed, for example, on a selected typewriter, and all the same people get a nice original copy. It could also be used for preparing articles for CATJ or other type of magazines. Another example is micros will be used in head ends. It would be used for character generators. Also, many of the character generators that are now available incorporate microprocessors in their designs. Also be used for what the screen is showing, cable games, which is a product that I work on right now called Computer Cable Vision. Cable games is generated by this CV computer, which is a microcomputer, and it generates color video output, which you are seeing now on the screen. It also has a voice synthesizer, which I'll try to pick up through the speaker here. As it says there, it's not easy for a voice synthesizer to speak. But these are the type of things that you can do with a cable microcomputer in a cable system. We also have, in the head ends, microcomputers will be used for two-way control, such as TOCOM's use of a two-way system where you're using it for alarm systems to keep track of subscribers and which alarm has rung and how to call the police or fire departments when needed. Similar things will happen in derivatives of a cube system, whereby you will have, in the cube system they're using fairly large computers, and you will be able to use derivatives of what they do there, maybe the better products, can be run on microprocessors. Micros will also be in the homes. As many people have probably read in some of the trade press, Gerald and General Instruments, who owns Gerald, and Mattel are working on a project that would involve hooking cable systems into microprocessors, microcomputers in the homes. There are a variety of services that can be worked that way. For example, you could have a wire service not only come into your cable system as a character generator, but send the data directly down the cable system, and the home user would pick which data he wanted off that wire service. For example, you could program in which stocks you wanted to look at during that day, and when you came home at night, you could get a review of how that stock did during the day. You could also pick off stories off the wire services that were of interest. There are those possibilities with the microcomputers in the home, but there already are thousands and thousands of microcomputers in homes all across the country. I have an example here of a Radio Shack computer, which I'll be talking more about later, which will probably become the standard microcomputer, I believe, in the future. There are also, Commodore has a PET computer, which many people have seen. There are the Apple II computer, and there are a variety of other hobby computers out there that have been for sale for about 10 years. About 3 to 4 years, and people have been putting home computers in their home for about 10 years. What I'm going to talk about today is the homebrew approach, about how you can do computers yourself, both making the computers yourself or writing computer programs yourself, and talk about how you can cost effectively use some of these approaches. The advantages of any homebrew approach is that you are saving money most of the time. There are ways where trying the homebrew approach, it can end up costing you a lot more money. The other advantages of the homebrew approach is that you can customize a computer application to your own system, your own application. And you also have the advantages of a homebrew approach is that it's a great learning experience, meaning that you will learn a lot about how computers work and get over a lot of the initial fears. The homebrew approach does save a lot of money in building computers, at least prior to 1975. Prior to 75, if you wanted a computer in your home, you had to go to one of the fairly large computer manufacturers, such as IBM, Univac, or whatever, and buy a computer. Or you could build it from scratch, which was the only way it made sense. And there were several people who did that. In 75, the first computer kit became available, and an Altair kit, which this computer I have behind me is an example of one. And thousands of people started buying computers. The whole hobby computer industry started with that computer. Today, though, it doesn't make any sense to buy a kit. The economic situation is completely reversed, where the situation for a completely assembled computer costs you less than building one yourself. The homebrew approach to computers generally does not make any sense anymore. The Radio Shack computer that I have here costs about $600, the minimum system, and to do the same thing from kit form would cost you at least twice as much. And you could easily spend 3 times as much trying to get the same type of productivity out of it. So it doesn't make any sense anymore to build your own computer. An assembled computer for most applications is sufficient. The only time it makes sense anymore to build your own computer is when you want to go and do some custom applications, or if you want to do it as a learning experience, to really get a good grasp on how microprocessors work, the machine language, and the ins and outs of a computer. And that, I would suggest, is maybe necessary for a lot of people, because as this computer revolution rolls on, and you use computers in both the office, head ends, and consumers have them in the home, you will want to know how these innards of these computers work. And it's a good way to get a good grasp on how these products work. The other thing is, if you're going to start getting into the process where you are building computers and you start getting involved, there are many magazines available specifically made for the microcomputer industry. I brought with me 5 separate magazines. See if we can get it without any gloss there. But there are at least a dozen different magazines available. And I have brought with me a complete list of such magazines, and it incorporates not only the magazines, the addresses, how to order them, and a brief 1 or 2 sentence description about what they do as a magazine, what their basic approach is. But if you're going to go and build your own computer for a custom application, you would need you can do this with the hobby computer. For example, the voice synthesizer, which I showed earlier, is a particular peripheral that is available for an S100 type computer. The computer also has a lot of other peripherals that you can buy from over 100 different manufacturers who make products for these computers. So it is well supported. You can't do a voice synthesizer on a Radio Shack computer, so you'd have to go to something like this. It's like, to make an equivalent, it would be like you can either go to a cable system and have your head end completely built by one manufacturer on a turnkey basis. That would be like buying a Radio Shack computer. If you wanted to do some special things that were not available all from one manufacturer, you'd probably have to go to something like, at this time, the S100 computer, a standard hobby type computer. The color video output that this device has is another unique feature that you can only get through this type of computer now. In about a year or so, I believe the Radio Shack computer will become the standard so that you can get all these type of features for a Radio Shack or a similar type of computer. While I'm mentioning the Radio Shack computer now, I might as well say that I don't work for Radio Shack and I don't have any particular interest in anything to gain by promoting the Radio Shack computer. I just believe that, my opinion, that will become the standard computer for the microcomputer industry. If you want to go to even a more complete custom-made application where you were using your micro as a switcher in your head end or some other particular application, like in my table games, what is done is the subscriber would call up and use a touch-tone telephone or a touch-tone pad to call into the computer. The computer would automatically answer the phone. When answering the phone, it would then prompt the computer to go in and play the games. The thing that I needed for the cable games was a telephone answering device touch-tone decoder, and I had to build that myself, and that is not extremely difficult to do. The unit which I have here is the prototype board that I built, which becomes very much like a wire wrap circuit, or it is a wire wrap circuit, which you can buy all the parts for in most electronics houses by mail, or going to the houses yourself. You get a, see if we can get a, as you can probably may be able to see in that angle, there are a lot of pins sticking up here about a half an inch or so, and what you do is it's sort of like needlepoint, where you're wrapping wires from one post to another in order to make electrical connections as opposed to soldering. Well, this is the type of thing you can do with the hobby computer. You can use functions like this. The main advantage of the hobby computer is that custom application, but that really is the only advantage now. Otherwise, like I was saying earlier, you should consider buying something like a Radio Shack or a similar assembled computer system already. You could do custom applications, like I was saying, with the switcher or alarm circuits in your head end for lighting or to monitor earth station or microwave functions. But generally, you may not want to do that. It involves a lot of work, but if you do, the hobby computer is the way to go. Talk about the homebrew computing now. It's different than homebrew computers. And the computers I was talking solely about where you were soldering, you were actually building from kits or designing from the ground up your own computer. Homebrew computing, you can buy a completely assembled unit, take it home, take it to your office, plug it in the wall, and you can start working right away. The kit form, it will take you probably a month at least to build the unit yourself. The difficulty, though, with either approach is that once you have the assembled computer all ready to go, is that the computer is probably the easiest part of this. The programming is the difficult part, and there are several reasons for that. The main reason is that the software is expensive. There's a lack of standardization. Thank you. There's a lack of standardization in the computer industry for a variety of things. I'll give you an example. I have a cassette recorder that works on this machine back here, and I have one that works on the Radio Shack computer. But they do not work the same way. If I was to take a cassette from this machine, I could not record it directly into the Radio Shack computer. And the same thing with taking the Radio Shack computer and using it in other computers. There is a lack of standardization. It's like an equivalence would be if you went to a record store, would have to make sure that your record player worked with the record that you were buying. There's also the fact that there's no one application usually is the same as another. For example, your billing system may be different than how your neighbor down the road bills. Generally, they work in a similar manner. The billing systems, you can adopt one program to work in another. We'll talk about how you can do that. Once you have your homebrew computer, there's a lot that can be done to reduce the cost of the programming. The major thing is if you buy a computer that is some sort of a standard, as I believe the Radio Shack computer and other computers are, you can buy custom packages already made for that computer and use them in your own system. We have an example that I will show later that Bill Marshall, who is here with me, we will demonstrate a system that we worked on just the other night on doing system design, powering. But once you come up with a standard, example, we could send you the program that Bill and I worked on, and you could use it in your system. So standards would be very helpful in reducing the programming costs and making programming available very inexpensively. It could be made as inexpensive as, for example, record albums are now. The simple cost of a cassette would make available to you a fairly extensive program. What I foresee would be happening would be, for example, microwave manufacturers or earth station manufacturers making available computer programs that they have developed to you on a cassette, so you can do some of your own earth station design and development or microwave planning, if there was a standard that people could use. The same thing with the line extenders in the cable powering and cable design itself. Different manufacturers, I believe, would make available programs, or other cable operators would have developed programs that you could use to design your cable system. Example, I was talking to one cable operator here at the convention who has worked on a program where he designs in the computer two different cable runs, an A and a B, using different cable, and he designs the whole line, and at the end of the program he gets a listing of the different parts that would be used and gets a cost comparison to see which would be the most economical. And he believes that in the past year and a half that he's been using this, that he has saved over twice the cost of the computer just by this program alone, and he's doing a lot of other things as well with his computer. What I'm doing as part of my business, I work for and president of Computer Cablevision in Washington, D.C., but as part of my business there, I also do consumer computers work. I am running a programming service for Radio Shack computers in that area, whereby I will sell within a month over 100 computer programs. I now have about 25 and have many more in order. These are made by people all over the country, and I will sell them similar to the way records are sold in record stores. I also run, in the same type of service for the computer club in the area, a program exchange, where people have developed programs, they submit them to me, and I distribute them to any other club members at no charge. I will hopefully be doing the same thing for the cable television industry, whereby I will have packages available and will be distributing them either for a minimum cost that will be affordable for any system, or people will make them available to other cable operators at no cost, and I will be willing to distribute those as well. Now, to reduce the cost, what I've been saying all along is that you need a standard. You need a cassette or some sort of medium where you can take the programs and put them in your computer that somebody else has already developed. And I believe that the Radio Shack computer will become the standard. And the reason I believe this is that the other computers that are available do not have the same features and are not available at the same price. The Commodore PET, which is the equivalent price of the Radio Shack, of about the same $600 for the minimum system, just does not have the servicing ability the Radio Shack has. Radio Shack has 6,000 stores around the country where they are selling these computers. Yet Commodore PETs are only being sold by individual computer stores around the country, and they cannot reach as far as wide as the Radio Shack computer can. Other computers are just generally too expensive. The S100 type computer, which I was showing you behind me, just costs way too much. The Apple II computer, which has a lot of nice capabilities, is still about $400. The minimum Apple II computer system is about $400 more than the Radio Shack system, and suffers the same problems that the Commodore PET has, in that it's not as widely distributed. The Radio Shack computer has a lot of nice functions and features that are much better than the other Commodore PET. For example, the keyboard on the Radio Shack is much more of a standard typewriter keyboard that most people are accustomed to. The Commodore PET is like a calculator, and it's very hard to type on. The other thing is the field support that Radio Shack will be giving to their computers. What they are doing in the Washington, D.C. area that I know of, they promise 24-hour repair turnaround if anything goes wrong with your computer. You take it in the store, 24 hours later you have it back. Plus, and this is very hard to believe, but this is what they are doing in Washington. Under the warranty, all the service charges are at no cost. But once the warranty period's over, the maximum cost for repairing the computer will be $24. There's already a lot of competition with Radio Shack to offer products, that work with the Radio Shack computer. For example, there is now a Selectric typewriter that you can get full IBM service and warranty on, that you can attach to the Radio Shack computer. So when you weren't using the computer for printing, you could be using the typewriter for your normal office use. There are also a lot of companies offering other electronics products for the computer that can save you money. There are two other things about the Radio Shack computer that are fairly nice, and one is that they've taken a modular approach, in that if the TV set or the monitor is broken, you can take that in and get that repaired and still have the rest of your system. Same thing with the cassette recorder. If the cassette recorder goes bad, you can hook in another cassette recorder and take back the one that's broken. The one feature that Radio Shack has not yet incorporated, but they have promised to do this, is that to have both upper and lower case on their TV monitor, so you can use it for word processing. But that will be coming along shortly. So in short, I believe the Radio Shack computer will be becoming the standard of personal computing. It will be a very nice device to be using in your home or office, and that it will be well supported. There will be many people using it, and there will be a lot of programs available. Homebrew computing and building your own computer does not make much economic sense anymore, unless you want to build a custom designed system such as the cable games, as I was demonstrating here during this talk. Bill Marshall, who's here with me, and I wrote an article last August in CATJ that dealt with using your system for using a pocket calculator in doing line extenders and figuring out tap values, and it was in the August 1977 issue. I ran into him in the elevator after just rereading the article because I was working on adopting that for the Radio Shack computer. And we went back in and the same night reprogrammed that into the Radio Shack computer. The next night, Bill got so intrigued that we started working on a program to do power design considerations for your system. And both these programs I'll make available if anyone wants copies of them. I'll send you a cassette of them. Bill, you almost did the complete work on that power system except for the graphics. Do you think you can do other programs on it?
I think probably I can. That programming, that unit is amazingly simple. It really is. It's in that basic language, and you tell it to print something, and it prints out whatever you want it to print. It's fantastic. It makes my little pocket calculator seem obsolete.
Yeah, really you can consider computers as just a programmable calculator with a few more features, like a printer usually and a TV screen for in this case.
Yeah.
The power design, why don't you describe what you can do with that, and maybe then we can go and show an example of how it works.
Well, this is just a basic power design program for determining your system powering requirements, how far you can go away from your power supply and whatever. And it starts out, it asks you the minimum voltage required at the amplifiers, the AC power supply voltage, and goes on, and then we have it set up in a graphic form where you start at the most distant amplifier, which you have to do in those type of calculations, and work back up, and it'll tell you the voltage drop and the voltage at that amplifier. And then at the end, if you go below the minimum voltage, it will stop the program and tell you the maximum distance away from that amplifier that the power supply must be placed.
Okay, maybe we can get to show how that works here. Maybe I'll get up there and see if we can get this to work right. What we've already done here is we've loaded into the computer the program prior to getting on the air here, so the program is already in the machine. What we've done is we've stored the program on a normal cassette and run it through a normal cassette recorder directly into the machine. All you have to do to activate the program is type run. Just see if we can. It's pretty grainy. Well, I'll read what it says here. This says cable system power design. That's sort of the title for the program. And it's asking what is the loop resistance per 1,000 feet. What would you use, for example, 1.5?
Anywhere along in there. It's just a demonstration.
Okay. Put in 1.5 ohms. Then what is the power supply voltage? And it's asked for either 30 or 60 volts. I'll give an example of what we've done here. I'll try to put in 50 volts. And it comes back and says power supply voltage must be either 30 or 60 volts, and asks you to enter the number in again. So we'll enter 30 volts. Now it's asking for a minimum voltage. And we've done the same type of thing here. We're using a 30 volt system. If you try to say the minimum voltage is 100 volts, it will say the minimum voltage must be less than the power supply voltage. So we'll say 22 volts here. So now we're going to a graphic display where it will give you a complete list of different amplifier locations, the current required at the amplifier, and the distance between it. So what's good numbers here, Bill?
Oh, about 0.5 amps.
Okay.
And, I don't know, 1,500 feet.
Okay, we've entered at the first amplifier 0.5 volts, 1,500 feet, and the voltage drop, it tells us there, is 1.125, and the amplifier voltage is 28.875. Go to the next, we'll enter the same number again here just for show you how this works. Now you have a voltage drop of 2.25, and the voltage there is 26. I can't read at this angle. 26.625, I believe it says. Want some other numbers, Bill? What do you think? 1.5?
1.5.
500 feet, just the difference. Keep punching some numbers in here to show you how this works. Okay, at this point here, when we've tried to enter the fifth amplifier, in doing so, the amplifier voltage there dropped below our minimum that we've set as 22 volts. So what it says is, whoa, the power supply must be located in this area. The power supply must be less than 317 feet from the amplifier number 4, which was the previous amplifier in there, before the last one we entered. And the total current from the power supply is 3.3 amps. I should note that we started with the amplifier number 1 in this example was the most distant amplifier. And that's the basis of this program. Okay.
That is basically a simple program, both to design, and the limiting factor on these programs is your imagination. You can make that program as complicated as you want to for your individual system. And believe me, if you get one of those things and start toying around with it, it'll get complicated pretty quick as you get to know the computer system.
Now that's just one example of what can be done. We did that in about 2 or 3 hours, I think, the other night. Bill, I think, can almost program himself by watching me do it. It's a fairly simple operation. And the other one we worked on was the line extenders. We won't show how that works. Why don't you explain what you did there?
Well, there, basically, it was a feeder design program, and we took the amplifier output and the cable and figured out the loss between taps and sized the taps accordingly. Now that program could be expanded to have a table incorporated into memory to pick out the taps for you and enter the through loss automatically and continue on the program. Maybe even with a break in there to put in an odd-sized tap somewhere to feed a extender or a apartment house or something. You know, there's no limit to what you can do with those programs.
Now this is just one area of using computers for your own use in a system and system design. I have some business programs that are available. For example, Radio Shack offers a program for, I believe it's about $20, a payroll package program whereby you can do your entire payroll and it will do all the computations for various taxes and with deductions that have to be made in your payroll. It can handle several. With the minimum $600 system, it can handle up to 9 employees. If you buy the larger, some of the options that come with the Radio Shack computer, it can handle up to 144 employees. So it has a wide variety just there. I have some other business programs. One is a ledger function, another is a more of an accounting type function, but they're rather basic things to be used either in the home or in small business. There are several other people who have written fairly extensive programs that use the floppy disk system that Radio Shack has available. Their units are fairly inexpensive. The unit I have here costs, you would need a unit that would cost about $1,000. And to add on the floppy disk to that would cost $300 for an extension unit and a $500 for each floppy you could add. You could add up to 4 separate floppy disks, so you could do a wide variety of data manipulation. Like I was saying earlier, you can hook up a selectric typewriter to be your printers if you want high quality print. Several people offer other printers that are much faster that you could use for billing or other functions. One's for $650, and the Radio Shack offers one for over $1,000 that works fairly well. Let me get back to, once you get beyond sort of the basic normal computer functions where you're talking about bookkeeping or accounting and that type of thing, if you want to do custom applications, I'll give you an example of what you can do by showing you in a little more detail here what I'm doing with the cable games. Again, the idea with cable games is that you were started up again here. Its color's right. You are starting with a microcomputer unit similar to this in your head end. Using that computer, you attach a video output, attach one line as an audio output, being a voice synthesizer, and you have a phone line coming in. You then have customers could call by watching, let's get back to this original one, a phone number that would be displayed on the channel. When no one is playing, it will go through a series of different screens promoting the channel, and you can add add different other promotions that you wanted. It has, as I showed earlier, don't really have hooked up very well, a voice synthesizer that says everything that is on the screen. The game what I have here in this original package would be that I'd lease is 5 different games that would be available. The basic games include a tic-tac-toe, a sound match. There will be a biorhythms. This is the screen right here saying thank you for calling once a person is called. And when they call, they would indicate whether they wanted instructions or not, or in this case we have programs, so they would just press any two buttons to make sure if there was a wrong number, you got rid of the wrong number right away. And then go through a series of instructions here about how the consumer would play the game. We have 5 different games available: the tic-tac-toe, biorhythm, a game called Sound Match, where the voice synthesizer, the computer will say numbers between 0 and 9, and you identify, you see how well you can understand, how well you do understand the voice synthesizer. We have a math practice game that we're working on that's basically for kids, a 1 + 2 = what, a very educational type programming that we're working on. We're also working on a game called Robot Capture, which has a robot running around the screen that goes very well with the voice synthesizer. And we have a game called Star Puzzle, which is one of many puzzles that we're going to be working on. At this point now, the computer will give a menu of the games that are available for people to play. Here it's showing that if you press button 1 on your phone, you would select tic-tac-toe, 2 Robot Capture, Math Practice, Sound Match. If 0, it'd go and show you the other games that are available. And this package would be updated every 4 months. Let's just show you what tic-tac-toe looks like here. As you can see, it has 15 colors available to it as the output. And we use most of the colors throughout. The games, tic-tac-toe does not have much motion in it, but the other games that we were working on, such as the Robot Capture and others, have a lot more action to it. The computer gives you a choice in this tic-tac-toe whether you want to be X or O. We'll take X, and whether you want to go first or not, we'll let the computer go first here. Then ask where we want to move. The computer takes the time to think there. It's pretty smart. It's going to end up tying this game, I think. Good game, a tie. Try to put the voice on there. Just said, do you want to play again? We'll play again here. Do you want to go first here? Well, this time we'll go first since we only tied it last time. Go in the center. Let's see if we can trick it here. Guess not. Each time there it's saying, your turn, X, which move? It's like all voice synthesizer. I believe I tied this game too. We originally had this program so it was unbeatable. But that wasn't very much fun. So we reprogrammed it so you can now beat it. Takes several times to play. What we allow is a person to play 3 times, and then the computer will hang up and ask if somebody else wants to play the game. If you don't answer within a minute, the computer also hangs up. And after 45 seconds, it will come on and say, I am waiting. And this little white square here that you see will start flashing. And if you don't answer within that minute, it comes on and says, I'm sorry, you took too long. And then go back and ask if somebody... It just said, I am waiting there. And you can see this white square is flashing a couple times. And pretty soon it will go to the screen saying, I'm sorry, you took too long. Well, this gives you some sort of idea of what you can do. This gives you some idea of what you can do when you start playing around with computers. There are a whole variety of functions that can be done. If you really want to get into the future of things, what's happening now with micros is that what is being marketed is there's more and more of an interest in robots. And instead of having a microcomputer sitting right next to your TV in consumers' homes, what's going to be happening, you're going to have something like this little drawing of a robot that running around a subscriber's home that you may be having to give service to. How about that? That may be a little far-fetched for right now, but there are commercially available robots being offered for sale in the computer hobby industry. The one that's out now is called a Turtle, which is about 5 inches high. It looks like a salad bowl turned upside down. It has a little beeper in it and has a pen attached to it so it can draw on the floor or whatever surface you put it on. And it can run all around from the commands of your computer. So that gives you the idea of the range. You can, if you start playing with your homebrew electronics and custom-made designs, you can do a whole variety of functions with digital electronics and the low cost of the computer circuits. If you start doing homebrew computing, where you start writing your own programs, you can write programs such as Bill and I have written here at the show to do system design work and business systems, accounting and other type functions. It's really up to your own imagination to come up with a lot of these different ideas and use them well. There is no reason to really be afraid of computers. They are really very simple to operate. You can just think of them, as I mentioned earlier, as programmable calculators that are just a little bit more complex. And that, like in the either example here, we're using TV screens as the output. As a calculator, you use either LEDs or sometimes printers. You can use typewriters as outputs for computers. The other example would be if you started using the data capability of a computer, whereby you're storing all your subscriber information on floppy disk, or you're storing into your computer for a system design. How exactly in a computer model, how your system should work, the complete layout. So if you have questions and you think, well, I don't remember what the signal should look like at this point, you could access your computer to look at it. So there is both a data handling capability of computers, as well as a simple programming or function capabilities similar to calculators. Thank you. This gives you, I hope, a good idea of what you can do. Bill, you think you're going to be getting into computers in a couple of years here?
I'll tell you what, it's something that I'm really looking forward to getting into because it's really interesting.
Yeah, you can do a lot. Do you see being used? How small is your system? Or large?
About 500.
So you think you could find an application there?
Well, I found plenty of applications for my little pocket calculator, but I can see the sky's the limit for these little microcomputers. Got to have one.
So I think you can be, like I said in the beginning of the show, it will be used in most every cable system within 5 years, and the question is really how many. I thank you very much for watching me, and I hope that if you have any questions, catch me after the show if you're here in Oklahoma. Thank you very much.